In this video for our microcontroller labs, we are now going to look at how we can use a microcontroller to control a servo motor through the use of a potentiometer. A servo motor is nothing but a precise motor that is used in robotics and other precision control methods. And from there we can now go to our Arduino Uno. Now we can select our component. You go to the component list and we can type Arduino, and we can now get our Arduino Uno, and what we need is a potentiometer, and we can now go to find our servo, and we can now get our servo motor, and we can now start our connection. We can place our Arduino, we can place our potentiometer, and it is connected to analog pin A0 of our microcontroller, and we can have 5 volts which control the operation of the potentiometer, and we can have the ground, and we can go to our servo motor. We can now connect our servo motor, and we can have the ground, and we can connect a power supply. And in this example we are going to use a 5 volts small servo motor. The aim is to see how the direction or the angle of the servo motor can be controlled using the potentiometer. And we can connect to pin 9 of this particular Arduino Uno. And now since our circuit diagram is controlled, complete, we can now open the Arduino Uno side by side with this Proteus to see how we can program this Arduino, so that by using this potentiometer we can control the angle of this servo motor. And now we have our Arduino IDE. By looking at this circuit diagram, we can be able to program this particular Arduino to control the operation of the servo motor. Firstly, we should include a library, and for this library we will have servo.h, where it will contain a full functional library code for controlling a servo motor. And once we include this library, we can now proceed to identify our servo motor. We can say my servo, and we can now give the integer value to our variable such as the port pin, which will now contain the analog signal which is coming in from the potentiometer. And once it is done, we go to the void setup, and we can now say my servo dot attach, and our servo motor is attached to pin 9 of this Arduino Uno, and we can say servo attached to pin 9. This is just a comment. And once it is done, we go to the void loop. This is the main code that will control the operation of our servo motor, and we give an integer value to the angle, and this angle is a variable that will hold the angle component that will be mapped against the analog signal from the potentiometer pin. And from there we can now map this particular analog signal to the angle of the servo motor. Therefore, we can now type map, and we have the analog read. We are now reading the analog signal coming in from A0 from the potentiometer, let's say port pin, and we can now give 0 to 1023 because of a 10-bit analog to digital converter resolution of the analog pin of this microcontroller, and we will map with respect to 0 to 180 degree because a servo motor will operate in angle between 0 and 180 degree only. And from there we can be able to say we are mapping the analog signal to 0 to 180 degree. And once that is done, we are now going to write this particular angle to our servo motor. Therefore, we can say my servo dot write, and we are now writing the value which is the angle to the servo motor pin, which is the pin 9 of this Arduino Uno, and we can give a small delay for 15 milliseconds. And this is our completed code that can be used to control this servo motor through the use of a potentiometer. By varying this potentiometer, we can be able to vary the angle in which the servo motor will operate. And now we can compile this code to see if there are some errors. Once it is done compiling, no errors, we are now going to export this particular file into a hexadecimal correspondence where it can be used by this particular Arduino Uno. And once it is exported, we double click on the Arduino, we go to our code, and we can select our hexadecimal file, and once it is done, we click OK. So now we have our code which is embedded in this particular Arduino IDE, and now we should be able to see how this particular servo motor will operate. And we can click the run button, and we can see the direction of the servo motor. And if we start to decrease the potentiometer value, we can see that it is now minus 90 degree. And when we increase the potentiometer, the resistance of this potentiometer, we can be able to see that it is now in the positive 90 degree direction. And we can now be able to see that when we decrease this particular resistance of this potentiometer, we can be able to see that it is now operating in a anti-clockwise direction, and it finishes at minus 90 degree. And when we increase this particular resistance of this potentiometer, we now see that the potentiometer is operating in a clockwise direction. And if we want to precisely select this particular servo motor to operate such that this is a 1 kilo ohm resistance, and if we start to decrease the resistance, And now we can set the angle. If we start to decrease the resistance of this potentiometer, we can now be able to see how we can control the servo motor precisely. And from there you can see there is a small initial change in the particular step of the servo motor when we start to decrease. Therefore, when you want to control such as 37.7, which is corresponding to the angle which is 38 degree of this particular servo motor, then you can put it to 63% of the particular potentiometer resistance. Therefore, we normally can be able to control this particular servo motor using this particular potentiometer. And now we are in the negative position where we have from minus 90 to 90, which is nothing but our 180 degree. So in that case, we can be able to control the step size of this servo motor, and this servo motor can now precisely control our position of the control position, such as a robotic arm or a control plant that requires precision use of a servo motor, such as for the packaging of equipment, or such as a medical arm that can be used to perform operation remotely. And from there we can be able to appreciate that the use of this particular servo motor can be precisely controlled using the analog signal from the potentiometer, and there will be more application of such servo motor we may be able to look at in our future discussion. And thank you for watching our video. If you like more of our content, you can kindly subscribe to our channel and share this video with your friends so they can also learn how to control a servo motor using a microcontroller and a potentiometer. And see you in our next video.